We're going to talk about SQL and FHIR implementation in Postgres. My name is Nikolai Ryzhikov. I'm CTO of HealthSamurai. In HealthSamurai, we are crafting FHIR database and FHIR server, which is called 8box. And for now, this work is distributed as a part of 8box. So we made decision to extract it into open source Firebase 3.0. You probably know the previous versions of Firebase, but we're going to extract this work from 8box and make it open source. So we were planning to do this year, but sadly it will happen next year. But I'm pretty sure it will. So, and what our interest in that? So we believe in FHIR-first systems. So we believe that the future system will be built on top of FHIR. So not only using FHIR as a standard, but using it internally. So Graham called it deep interoperability. We call it FHIR-first or FHIR native stuff. And 8box position our database and FHIR server as the backend to build the application. And when you're building application, you need a lot of flexibility and you need the control of your data. And we're proving that we can build FHIR native application with our customers. So that's our interest. And we were looking for the chance to standardize it. So, and I participated in the first version and in the second. And I really love to work with this team of smart people. So thank you guys. And thank you that we did the first release. Okay, so a little bit intro, because I think we missed this part. So what type of runners we can expect, like view definition runners? So I would separate it into ETL style runners or in memory and ELT like in database. So probably if you're working in analytical stuff, so you know what ETL means and ELT. So ETL means that we extracting, transforming, and then we injecting and loading. Yes, and that's like you building ETL pipeline. And what we saw that essentially the puzzling, maybe, yeah, and the Google OpenStack, they are ETL style stuff. As well, the JavaScript runner, which is a part of our specification, is ETL style. And another approach is do it inside database. And this is quite popular now, the modern approach. ELT, when you initially load data losslessly into the database and then transforming in database. So ETL, quite easy to implement, especially if you have a FHIR-pass engine. So you're getting data, bulk export, subscriptions, you in memory, consuming view definitions and translating FHIR resources into more flat presentation, producing, files or inserting into the database table. And and that's especially designed to simplify implementation. So tests are unit tests, so they kind of pick one aspect at a time. So it should be easy for you to implement. And the JavaScript implementation in less than 300 lines of code. So essentially you have to implement these 4 functions, a little bit more, but like select, column, for each, and union. And this is described in functional model. And whenever you're ready or you pass half of the tests, please pull request us and you will be added to the matrix, implementation matrix. And you see that, yeah, the flat quack already here. And it's passing tests. So there's a special format. You should publish the result of your tests in some S3 bucket, and this view will grab it and draw it in such a nice form. Okay, so that's about ETL style engines. Yeah, I encourage you to implement it. So we have few of them in Java. We don't have such in .NET. I know we have one in Rust. We don't have in Go, so please do contribute. Another approach is ELT, and the idea that you have modern databases can store FHIR almost as is. So it can do Postgres, it can do Spark, BigQuery, DB. So, and the idea that you can do this transformation inside database. So what's good about this? So that ELT could be much more efficient and faster than ETL. Because in ETL, you have to get data into memory, you have to transform and so on. Okay, you can scale, but so, and ELT, it's like, you can do it easily, you can query. So that's good part of ELT, but the bad part, it's really hard to implement because there's really a lot of corner cases and it's like 1 order of magnitude more complicated implementation than implementing ETL, especially if you have a FHIR-pass library, as I told you. So ETL is nice about that. It's really easy to implement. It can support the full FHIR-pass, and if you will try to translate it to SQL, like in doing ELT, you will understand how hard it could be. So, and we will making another step because we are Postgres based. So the idea, what if we can provide you FHIR server with the first class SQL and FHIR support? So, and why are we interested in this? Because yeah, we know that the FHIR search is not enough. So we want to provide you more control over your data. You can do this using Postgres specific stuff already, but for now we have a very nice standard way to like flatten data, get the views, and start using it in your application, like, I don't know, and reporting, making reports, dashboards, and yeah, so we even call that SQL should be your second API to your FHIR data. Okay, so now let's jump into implementation. So first of all, how do we store data in Postgres losslessly? So we just use binary JSON. I'm proud to be the friend of guys who implemented binary JSON, so we start using it since the beginning. It is like pre-parsed JSON in Postgres, and that means that the cost to access elements of this JSON is very low. It's almost the cost of accessing the column in a database. And Postgres is coming with a bunch of JSON functions and JSON pass engine, which allows you to work with the nested elements in a JSON, nested attributes. So, and below the sample query, so you can run again and what we know that most of experienced engineers are quite happy with that. So when you get how to work with the nested data, when you learn all this Postgres function, you could be extremely efficient. Yes, but what we know that, yeah, not everybody feel comfortable with such type, especially the tools. The humans is okay, but the tools. So we decided to write this implementation which translates view definition into the SQL query. And here is an example. So the ideal is this ELT tool, just getting view definition and translating into very, very Postgres specific query. Yeah, so how it works internally. So just a hint, and I'm really interested. So we have a like done implementation, and this is like second implementation of SQL translation. I'm really interested. I will take a look how it's done. So, but in our case, what we're doing, so you parsing the view definition, especially you parsing the FHIR path expressions, and we're representing this as an IST. You may think it's a closure, but read it as a JSON. So you may think it's like deeply nested JSON with a tag and left, right, and stuff like this. And then we try to do everything as a val. A val means that we walk through the tree and calling for each tag of the IST node, we calling specific function, which tries to turn this node from, let's say, FHIR path into JSON path or into the SQL. So in this eval phase, it's quite easy to implement. It's like set of pure functions which translating different nodes from one representation into another, and you're translating into SQL IST. So you need some SQL IST. If you don't have, it's better to invent it. So, but not all of rules can be done that way. And after that, we're doing like additional rules, which are trying to match specific patterns and apply and like rewrite the IST. So especially there's a problem, for example, with the join function. So we're lucky in Postgres, most of FHIR paths can be translated into JSON paths, and that's amazing. But when you go getting to the, when it's not possible, so then we should do a lot of tricks, like because we're getting out of JSON paths, so we should start using SQL functions. So it's becoming quite tricky, and there's a lot of corner cases. Yeah, whenever you're able to compile this query, view definition into query, you may use it in a different way. So you may create a database view, you may even materialize it as a table and log a table, or you can use it as a query. So, and the next is going to be the demo. So you can run it, just run 8box locally. I would recommend do it locally, or you can run it in Sandbox, and we will take a look at the open source view builder. So probably maybe let's start with a view builder. Oh, okay, so let's start with 8box. So you can go in 8box and spin off the instance in the cloud. So you will get, or you can install it locally. It's free for development. And locally in 8box, you will have, we have notebooks. It's kind of similar to Python notebooks, but much more simple, just SQL and REST. And here should be published SQL on FHIR talk by me. So in here is the steps. So, and we will walk through the steps one by one, and I will explain some concepts. Yeah, so first of all, that's nice when you have SQL access to your database. So I don't know, is it visible or not? So let's make it like this. So we can access these passions through the REST API. So you see, we look by. So this is transactional ID, time of creation, update time, resource type, status, and the binary JSON. So that's how it looks. And essentially what I told you, that if you know the Postgres function, you can query data. So that's how we worked before view definitions. We implemented view definitions. And that's what view definition can do for you in a more declarative way. So for that, let's jump to the view builder. So this is open source project. It's quite young, so there are a lot of bugs, but it's quite nice. So you can start building your view definition and it will be drawn automatically. So guys even try to support auto completion through the FHIR schema. Let's say birth date. And when we jump to difference, so there should be, okay, so run, let's run it. Come on, yeah, it's just different order. And okay, and in real time, you may see how the result, you're getting results, and as well here is a SQL tab, so you can see what SQL was generated. So if we look closer at it, so we can see that we abuse the JSON path a lot. For some stuff, we need lateral joins. It's kind of similar stuff what everybody doing. Yeah, that's it. So feel free to play with the view definitions builder. And the link in my presentation should just jump and play with it. So, and I hope that this project will be integrated not only with the 8box and FHIR-based, but with the others engines. So, and you will be able, to build your views using Visual Builder. Okay, now let's jump back to the notebook. Okay, so what means like we can post the view definition into the server? Okay, so now it's a little bit broken, but let's fix it. So we drop the view. This is a power of SQL, so I can do a lot of stuff with the data quite quickly. So let's put the new view definition to the server. So we see it was successful. And after that, in a schema SQL on FHIR, so we've got the view. So, and we can see what's inside this view. So just using Postgres function, get a view definition. Now let's take a look how it works. Let's query this view and explain, analyze to understand what's going on inside. And we see that internally this view call original table passion. And we here use a like field column date of birth, but internally it is translated by Postgres view definition into this huge expression. So what's interesting that potentially you may index such type of expressions, and these queries on top of view will be quite fast. Doing that, what's nice about the real view, that it is real time. So when you're inserting data into the table, it is available for analytics right away. So because we don't yet have a age function in our FHIR path subset for view definition, so we can create another view on top of our view and let's say add the patient age. And now we're getting quite common model for the patient. So it's anonymized, only it's age pre-calculated, so you can do, and you can run it like monthly. Okay, yeah. After that, you're welcome to do any aggregation queries. That's what we don't have with the FHIR API, but now you can do it on a transactional database on your application data quite quickly. So we can jump into Grafana. So if you install 8box locally, you can connect directly to the Postgres. Okay, let's save it. So, and I will share the Docker Compose file, and then you can go and build the views. So for that view, let's just see how it's done. So you may use Builder, but for me, it's much simpler to use the SQL directly, and I like group by 10 years. So that's how we can get this view. Maybe let's group by 5 years, like this. So, and this dashboard can be refreshed and it will be live. Yeah. Okay, let's jump back to notebooks. We can load conditions. So I will skip this stuff again. So query conditions, 50,000, build the view definition on top of conditions. And for example, for my age, let's say 40, 45, like that. Okay, so we will skip this part about encounters, but you can do the same stuff. What's interesting else? So here's some aggregate query, but let's see what about materialization. So when we're doing the query on top of view definition, for example, like that, so let's see what's inside. It's quite inefficient. Again, so Postgres is extremely fast, but it's not the best result. So because the final query hit the table, and there's a problem with the JSONB in Postgres. It take a lot of space on the disk. So the Postgres essentially very optimized when the tables are skinny, like just columns. That's why we can play and, for example, materialize the view, creating unlogged table, for example, or creating materialized view. Let's create almost no difference for that. Okay, let's So let's create already exist. Okay, so it was created, and now let's run on this, and you see that execution time is much more smaller because it fits the memory, so Postgres can do it very efficiently. And the same will work with the materialized view. What's nice about when you're using unlogged tables, if you don't know, the unlogged tables mean it doesn't write into replication, or you can use materialized view, that you can build indexes on top of unlogged tables and materialized views. So that's when you really want to get most of performance. There's a lot of tricks in Postgres, so how you can do this. Postgres is not intended to be analytical databases, so it may work for some dashboards and reports where you manually build the indexes. It can be extremely fast, but like for drill downs and other stuff, I would recommend still use like columnar databases. But most of columnar databases like DuckDB, I don't know, ClickHouse, and other can easily get the data from Postgres, usually like by clicks. So we have a lot of customers who use Power BI. And when you have a flat views, you can connect the Power BI and we'll take the data from the Postgres views into the internal columnar storage, and then you can click your case. So what else? So in 8box, and I think that's future we're going to discuss in SQL and FHIR. So we have what's called 8box query type resource. So the idea of this resource that you can turn on the SQL into the REST endpoints, because you definitely don't want to expose your SQL to the rest of the world, but you can wrap the SQL query into the endpoint. Here we can do this by creating this 8box query. It can be parameterized. There's a link to documentation when you go through these notebooks. And then you can call it. So this is not FHIR, yes, but when you're doing application, so you want to build some dashboard reports, so feel free to do that. And yes, so that's it. Let's jump back to the slides.
Yeah, I think there is also a question on QA, but I'll quickly ask mine. I mean, first of all, great presentation. So maybe 2 years ago or more than that, I don't know, a while back, I did some experiments with JSONB in Postgres. And one of the performance issues that I had was it was making poor decisions when we were doing joins. Let's say if I am joining my observations with my patients, sometimes that join part was extremely slow. And that was because it was making a bad decision on what join algorithm to use. And my guess at the time was that because these records are like JSONB, then it doesn't have proper statistics on the frequency of, for each field. You see what I mean? Did you hit that kind of problem at all?
Yeah, that's well-known problem. That the JSON, binary JSON column doesn't have a statistic, but you can make this statistic if you do like functional indexes. And when you build functional indexes, so then index have a statistic and it will work. So and usually looks like that. So you're writing expression, you're extracting like, let's say, reference, and you indexing with a bed tree, and then bed tree have a statistic, and then the planner gets the right plan. And it could be extremely fast, almost the same speed as there. The big problem with the JSON in Postgres that the Postgres use fixed pages, which is like 64 kilobytes, and it doesn't work very well with the big JSONs. And Postgres, at least like the open source version, there's some commercial version which can like archive data on the pages. But when you're working with the open source Postgres, and so then if you have a huge JSON, they will be tossed, and then your performance may just die. So then Postgres like small records. So that's a problem, especially when you start working with like claims or some huge, like, I don't know, EOBs, they could be huge and they can drop your performance. Yeah. So that's the trap. So for us, the most important update was the support of JSON path. If you're not aware, there's a SQL specification, I don't remember which year, were published where the JSON path language was introduced. And when the Postgres were able to support this JSON path, we throw away our custom extension. It was a very small subset of FHIR path written in C, but yeah. And we now can use the standard FHIR path. And when you start playing with the Postgres implementation, you will see how actively we are using the JSON path to do that. Essentially, the JSON path, it's like maybe do support features similar to half of FHIR path. And it's standard as well. So this is an interesting option. So I'm even thinking like introduce JSON path as an alternative language for the FHIR path. Okay, any other question? I have a couple more minutes. Yeah, I will post my slides. Feel free to play. So it's quite easy to like run 8box in a few minutes. all the data and play with it.
All right. Yes. Thank you, Nikolai. Oh, John, your hand up.
Yeah, I just thought I'd ask what pattern do you see in your customers who are doing analytics off the database? So is it taking a view, materializing it, refreshing it at some sort of interval, or do they actually want to make some completely separate replica for analytic purposes so it doesn't sort of impact the operational database by running sort of big, heavy analytic queries?
Yeah, that's definitely depends on use cases. Yeah, for example, there's a very interesting cohort of our customers who are building EHRs, like FHIR-first EHRs. And they really want like transactional data, real-time data for the dashboards. Even like encounter list is a not so trivial, yes, because you should join passion, like location, encounter, probably like practitioner or something else. So even like making EHR encounter list is a challenge, yes, and the SQL and FHIR could be the solution for that. And that's one use case, people using it. But for more analytical stuff, some people prefer to have a replica, maybe logical replica. There's a trick in Postgres, so you can replicate logically into different database, and then you can change the schema, so you can add additional tables to that replica. So there are different patterns for that. So what we want to start supporting that, like exporting view definitions into columnar storages, because yeah, when you just like start working with ad hoc analytics, definitely columnar databases beat Postgres like few orders of magnitude. Because Postgres is good if it's indexed, yeah, it could be like 10 milliseconds, yes, but you're not gonna index everything. Yeah. So especially like for transactional database, if it's your application database. So there's a bunch of different patterns. Yes. And I can think like all possible patterns. But having like at least basic analytics in your transactional base is quite good, and it's quite common. Yes, it's traditional approach. So people sometimes want to do that. But it should be careful. Yeah.
All right. Well, we are at time for this session. Thank you, Nikolai. Great presentation. Just one quick thing, one question I had for you. Is the view definition builder, is that available currently?
I send the link to my slides, and I can copy the link to view definition separately and send it again. Yeah.
Okay, great. Because I think, folks are starting to get interested, and probably, one place to start is to start writing view definitions, start creating them. So just definitely wanted to put that out there for folks. A visual builder for view definitions could be really interesting if you're getting started. So
that's beta software, so feel free to report any bugs to us. So I encountered a bunch of them when like preparing this presentation. So yeah, feel free to report.